Hi friends, welcome to follow up. Let's have a look at problem 2750, ways to split array into good subarrays. In this video, our goal is to demonstrate how to analyze the problem. As for the coding part, once we digest the idea, so it's rather straightforward. So here we are given a binary array called nums, and a subarray of an array is called good if it contains exactly one element with the value 1. So we want to basically count how many ways to split array nums into good subarrays. So here we need to pay attention to the return. So we need to return the result in the sense of modulo this constant. So here we have two examples. In the first example, the return is 3. So it actually lists the 3 ways. And in the second one, it's a very special case because it contains only one, a unique one. So we need to include all the zeros in any split, but we need to also include this 1 because it's a unique one. So the output is 1. So here the constraint is the following. First, the length of this list is bounded above by 10 to the power 5. So this is a decent large number. And secondly, this array is a binary one. So with that said, let's look at the analysis. So analysis actually is just very simple. We want to use two observations to demonstrate the idea. So here we are going to use example 1 as an example. So here we appended some leading zeros and some trailing zeros. So our first observation is that the prefix zeros and the suffix zeros do not affect the final result. The reason is that they must be included in the first and last good subarrays, respectively. For example, in the first array, you need to always include this this 2 zeros with the first one. So similarly, in the last 4 zeros must be grouped together with the 1 in here, right? So this is the one observation. So in other words, so this list with trailing zeros and this one without trailing zeros yield the same result. So this is the one. And the second observation is that, so we can consider this one, right? And then if we count the indices of ones, actually more precisely the differences of ones. So here we have this one at index 0. So this is the index 3. This is the index 6. So the differences are 3, 3, right? So then we return 3 by 3 times 3. Then modulo this constant, but it's still 9 because this number is very small. The reason is that, so if we consider start, if we include this one, so we can ending at this one here, or we can ending at this first 0, we can ending at this second 0, but we should end before the second one, right? So this provides us 3 possibilities. So if we ending at 1, it means for the good array, including the second one, it should start from this 0, right? In other words, it's corresponding to the cases or possibilities for start corresponding to the second one, right? So this way, we just need to consider the indices for the ones, or more precisely, their differences. And then we do product of all these differences, right? And then we get the result. So that's the main logic here. So once we grasp this point, then let's do the coding. The coding part is actually rather straightforward. So first I'm going to introduce a constant. So let's say 10 to the power 9 plus 7. So this is not necessary, but we just want to write the logic in a more clear fashion. So we shouldn't forget to modulo this constant, right? And then we can use list comprehension to find the ones, right? So basically, I for I a in enumerate nums if a equals 1. So this way we find all the indices for the corresponding ones. Actually, this indices is not essential, but the difference, the corresponding difference sequence, in other words, their relative distance is crucial, right? So now let's consider the difference sequence. This is actually I I minus 1 for I in range. So we start from 1 and ending at length of this capital I. So first I'm going to treat a special case. So if not I, so it means that this list contains no ones, so it's impossible to find a good subarray. So we're going to return 0. This is also a special case. So next, we just need to do products of elements in the diff list. So there are a number of ways. Let's use a brute force way or a scratch way. So we are going to have a result equals 1, and then for d in diff, right, result to multiply equals this d, right? We multiply the result by d. So for safety, let's modulo this constant. So finally, we just need to return the final state of the result variable. So here you can also use product or use reduce, but don't forget to modulo this constant. So with that said, let's first do a test. Yeah, it passes the example we cooked up, right? So now let's look at another example. Let's look at the generic case. Yeah, it passes all the cases. So actually in my first try, we forgot to modulo this constant, which leads to wrong result. So with that said, basically that's about it for this video. As we mentioned, so here the crucial thing is the relative position or the index difference of the ones in the list. So with that said, that's it for this video. Thank you.